Hello, amazing people, and welcome back to this wonderful discussion still on how to use the quadratic formula. This is the third class, and in this tutorial, we have these questions to answer. Like we said in our last discussion, this question is going to lead us to what we call the complex roots. So ensure to stay actively to see how to solve those quadratic equations that could result to complex root. Remember, the complex roots are those ones that are not real, and for it not to be real means they cannot exist on the number line. You can have such a root, like you can have something like this. This is our x-axis, this is our y. So you can have it this way, you can also have it this way. You see, it's not touching the x-axis. So when you have it this way, it is said to be a complex root. So let's see how to solve those ones that involve complex roots. I hope you are ready. Now let's begin with the first one. But before then, I hope you have not forgotten your quadratic formula. And it says, if you have, this is a general quadratic equation, ax squared plus bx plus c equal to 0. And we said from this equation, we generated the formula, which is x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. We are going to talk more on how this formula was generated when we come to completing the squares. Now, to solve this, let's remember what we are given. So we are going to begin it with solution. As usual, I'm going to take the first question. I will leave you with the second one to try. So we are beginning with solution. So we are having 3x squared minus 5x plus 3 is equal to 0. Okay, so your duty is to identify your a, b, and c. So your a is the coefficient of x squared. So you come to this place, your a, the coefficient of x squared here is 3. Did you see that? So what is the coefficient of your x, which is your b? From here, you have it that the coefficient of x here is negative 5. So our b is negative 5. And our c is 3, which is the constant. So we are going to plug these values into the formula. So we are going to now have x is equal to negative in the formula. Your b has a negative 5, so we put it inside the bracket. Do you see? Negative sign is in the formula. Your b has a negative. Then introduce plus or minus square root. Your b is negative 5, so we're going to have negative 5 square it minus 4. 4ac is 4 times a times c. So what is your a? Your a is 3. And what is your c? Your c is also 3. And this is all over 2 multiplied by our a is 3. So what do you do at this point? You are going to simplify. And if you do that, you're having x is equal to negative multiplies negative is positive. So we have positive 5 plus or minus square root of negative 5 squared is negative 5 times negative 5 to give us 25. So we have 25 here. Then multiply 4 by 3. 4 times 3 will give us 12. And 12 times 3 will give us 36. So we're going to have negative 36 all over. What do you have next? 2 times 3 will give us 6. You see, it's becoming interesting. So we're going to have x is equal to 5 plus or minus. If you subtract this, it's going to give you square root of negative 11 all over 6. You see, we're having a negative sign in the roots. And if you could remember in our first tutorial, we said that when the inside value, which we call the discriminant, is less than 0, that is when it is negative, we say such is complex. So you see it's manifesting now. So it has become a complex root. So what do you do at this point? It's no longer a real value. So what we are going to do is we are going to take care of this negative sign. And if you do that, you have to remember that there is something we call, because to remove this negative sign, remember what you have as the imaginary unit. The imaginary unit, we usually use I to represent it, and that I is given as square root of negative 1. Okay, so what do? We're going to apply this here. Now watch what we are going to do. So this is going to give us now, we're going to have x is equal to 5 plus or minus. Remember, when you have square root of negative 11, it is the same thing as negative 1 multiplying 11. I hope you agree with me. All over 6. So in that case, if you use the rule of radicals, if you want to know more about radical, I will leave the link in the comments. It means we are going to have 5 plus or minus, then you can split the roots to have root of negative 1 and root of 11 all over 6. Did you see that? So what is this root of negative 1? The square root of negative 1 is taken care of by I. We usually introduce this when it is forming a complex root. I hope this is clear. We call this the imaginary unit, okay, or the imaginary number. So in that case, we are having x is equal to 5 plus or minus, this will be replaced with I. So we have I root 11 all over 6. So let's conclude. In our conclusion, what do we say the value of x is? So we're going to have it that our x is equal to 5. You take the positive value, root I, we have I root 11 all over 6, or 5 minus I root 11 all over 6. Remember, 11 is a prime surd, okay? It cannot be reduced. So that's why we're leaving it this way. Supposing you have such that can be reduced, do well to reduce it for better understanding. And this becomes the value of our answer. And I hope this really answered a lot. Remember, you have to try this. Trying this helps you to know if actually you understood the concept, and you can drop your answer in the comments. You can also ask questions for clarity. And if this tutorial really answered a lot for you, don't forget to tell us how much in the comment section. You can subscribe for the more you'll get. Share this tutorial with your friends. I will see you in our next class to talk more. Till then,